Good afternoon, everybody. On behalf of Sawmilling South Africa, the Department of Trade and Industry and Competition, Earthworld Architects, and the Universities of Stellenbosch and Pretoria, we welcome you to the next edition of our Talking Timber webinar series. If you don't know by now, but my name is Samantha Charles, and I'm your host for this morning or this afternoon. The purpose of the Talking Timber series is to promote the use of South African timber, preferably locally grown and locally processed where possible in the built environment. And with the built environment responsible for approximately 40% of global energy-related carbon emissions, sustainable timber and engineered wood have the unique potential to decarbonize the built environment both quickly and at scale, while supporting urban development, rural economies, and of course innovation. But South Africa is ripe for scaling up the use of timber in construction, as our speakers will share. However, many perceive wood as rudimentary or perhaps weak, maybe reserved for log cabins or our kids' Wendy houses or the tools, a place for our tools. But for mass timber structures, there's a significant opportunity for innovation, localization, and employment creation. And with that comes the need to learn more about timber, and that's why Sawmilling South Africa and its academic, government, and industry partners have put this series together. So today, our experts will cover construction detailing for mass timber buildings, and I will now hand over to the people in the know, and I'll ask Bram de Villiers from Earthworld Architects to make some announcements and do the introductory remarks and introduce our speakers. Over to you, Bram.
Thanks, Sam, and thanks for the introductions. I just want to first bring your attention to our timber conference. It's this year the conference is, or for the first time, it's in Pretoria, at the University of Pretoria, at the Future Africa campus. And we're very fortunate that SCALC has put this amazing program together for the conference, and it will focus. The conference theme is Growing Timber Connections, and it will focus on bringing all of the people in South Africa together that are working in the field of timber construction. And for the price of $950 per person, I think it's a fantastic opportunity to connect and to share some knowledge about what we have been busy with in the last couple of years in South Africa. There's the program, but please register on the details are there. It's on the PRA website, www.pra.org.za events. Click on events, and you can register for the conference. I really think at that price, it's a fantastic opportunity to connect to people in the industry. The second workshop, which is the timber frame design and construction one-day workshop. Philip Crawford is organizing that, and there again, the bookings, you can contact Philip Crawford via email. Again, a fantastic opportunity to get local expertise in the timber frame design and construction for that workshop. And then just to make your attempt again, the Wood app, please visit the app. There's some wonderful courses on that app, and nice thing is it's for free. So you can just click on any of those courses and you can do those courses online. Wonderful app. Please visit that. I'm going to introduce our two speakers for today. Our first speaker is Mark O'Connor from Rothoblaas. Mark is the area sales manager for Rothoblaas South Africa. My own notes is Mark is really passionate about timber construction, South Africa. He's also passionate to help local contractors, architects, engineers to construct good quality timber buildings. His talk today will focus on the connections, waterproofing, and acoustic details for timber buildings. And thank you, Mark. And our other speaker today is Michael Kloos. Michael is a structural engineer. Since 2020, Michael has dedicated himself to building with timber as well as alternative building materials. His primary focus is mass timber, and he has designed a number of CLT buildings, mostly in the residential section, as well as rapid built modular systems. Michael's talk today will focus on structural connections for mass timber buildings. And I really want to thank Michael and Mark for sharing your expertise and knowledge with us today. I'd also like to welcome Professor Dr. Skalk Rothoblaas. He's the York Timber Chair, and he's also the organizer of this year's Timber Conference in Pretoria. Thank you, Skalk, for assisting in the Q&A session. Also, Marcus van der Hooven from MTT. Thank you, Marcus, for also fielding some of the questions in today's Q&A session. As Sam said, please post your questions in the Q&A box, and we'll after Mark and Michael's talk, we'll field the questions on the Q&A. But Mark, I think enough said, and the floor is yours.
First slide that I would like to present to you is just a few notes on it. You know, the importance of construction is paying attention to detail. And a lot of the aspects that I'll be touching on there are quite interlinked. So, for example, your connection to the ground is very, it follows the same principles as sealing around doors and windows in terms of your waterproofing details. Air and wind tightness will also affect, and the detailing of that will also affect how the structure behaves in fire. So, yeah, this is just a real general overview. Michael will go far more in depth in the actual engineering, but I would just like to sort of share some of the details that we look at and some of the engineering sort of guidelines. So, of course, where do we start on any building? It's connecting to the ground. One of the golden rules with timber construction is timber can get wet, but the most important thing is that you need to allow timber to get dry. So, of course, as you can see in the first slide, I beg your pardon, as you can see in this slide here, you want to always avoid direct contact with the ground. So you would be putting in a series of membranes or sealing profiles to prevent sort of a lateral movement of water. And also you want to prevent rising damp or capillary action from concrete entering in the base of your timber structure, be it CLT, timber frame, whatever it may be. And then, of course, the following step then is if we're creating a waterproofing layer, how does one actually fix the panels down to the concrete or to the substrate? And that follows a few basic engineering principles. Generally, we would be talking about your hold down forces or tensile forces, as well as a sort of a shear force or a sliding force. Typically, these forces have always been solved, or traditionally, certainly in Europe, these forces have always been solved with the likes of hold down brackets. There's an example of it. And you'll see in this slide on the left-hand side, you'll see there's a black sort of strip underneath your cross-laminated timber panel. And that is a waterproofing profile to stop capillary action entering the underside of the CLT panel. On the right-hand side, you can see you've got a hold-down bracket, which will connect to the wall underneath. Now, in my experience in South Africa, we don't really use these brackets that often, simply because although your sort of cost per kilonewton is probably the most cost-effective with these type of systems, you do have an additional material cost in terms of hiding them again. In Europe, they're a bit more, wouldn't say fortunate, but they would be hiding these panels in any event with insulation. They would need to do it. In South Africa, we are still very much have in the tendency to keep the CLT, cross-laminated timber panels, exposed, which also brings its own set of challenges when it comes to how does one put in services into these buildings. This is an architectural element, and it can be solved with a number of different techniques and ways of detailing it. This is a typical, if we go back to this slide, your typical hold down brackets or WHT plates in Rothoblaas terminology, as well as Titan plates. You can see that's a typical internal detail and an external detail. That's very, very typical, very high values, engineering values for multi-story timber buildings. And you'll see the black and white tape, that would be an air tightness sealing tape fixed to concrete. These plates, just very fundamentally, would be fixed either with round edge screws that you see on your right hand side, or a ring shank nail in the middle. The advantage of a screw, of course, you can remove it. The advantage of a nail, it goes in quite quickly. Ring shank nail, you really struggle to remove without something like a crowbar. You'll also, if you want to try and remove a ring shank nail, you probably, the likelihood of damaging your CLT panel is quite high, as opposed to something like a screw. Conversely, your nail is much more cost effective than your screw, but you're also achieving much higher engineering values by using a screw. So often it's a play off between cost versus convenience, or cost versus speed. In our market, we find that labor compared to the rest of the world is relatively, well, I suppose it's a contentious subject, relatively cost effective if it's productive, of course. Whereas in other parts of the world, labor is extremely expensive, so they might want to invest more in hardware in order to speed up construction times on site. These are some of the basics. I'm going to illustrate some different systems that we've got to connect to the ground. I feel like I'm cheating showing you these videos instead of talking to you, but I feel that this really illustrates it way better than I could explain it. So please bear with me. All right, great. So as you can see in that previous video, one of the really golden rules when it comes to building with any kind of modular structure is you want to start on a very, very even base. If you, and I'm sure any of us with a bit of construction experience, if you're not out on if you're out with your levels when you start, when you're 10 or 15 meters up, you're gonna be extremely out. So with the Alu start system, it really, really helps to level out and create your setting out for you in a very uniform way. And the grouting is obviously that's there just to illustrate that you can level out your Alu start with grout. You know, in my previous life, I was heavily involved in concrete, and my boss used to say the only time a contractor gets concrete perfectly level is by accident. But moving on from that, the next step is once we've got the first panels up, we need to start joining them together. So this is your very, very typical construction detail. This is called a spline joint, and this is done with a countersunk wood screw. In Rothoblaas language, we call this product a HPS. And usually you'll be inserting one HPS, 6mm HPS every sort of 20 centimeters on either side. The beauty of this is that you're not losing any of your length of your CLT if comparing it to something like a lap joint. The countersunk head wood screw, I think we're all quite familiar with. It's essentially an oversized chipboard screw with engineering values and a Torx head. Our product data sheet comes with a lot of calculations, design software, and that sort of thing. So you really know exactly what sort of forces these screws can resist. The next version of this product would be a large head screw. So these are the two most commonly used partial threaded screws. These create a pulling effect in timber construction. The large head screw has got a larger head, a built-in washer, and one is generally getting higher engineering values using these large head screws. Very, very commonly used in roofing for a purlin truss connection. The next product I want to discuss, or the next type of screw I want to share with you, is a full threaded screw. And I've never seen these until I started working with Rothoblaas. These screws, they don't work in tension. They create almost like, I beg your pardon. They create like a tensile force, a bit like reinforcing in the bottom of a concrete beam. But you'll be able to see in the video how these screws work. You cannot actually tighten anything up with these screws. So if you have two pieces of wood and you introduce the screw into the two pieces of wood and there's a gap between them, you will live with that gap. But hopefully the video explains it suitably. One thing with the full thread screws worth noting is with the event of hidden fixings for beam hangers, timber to timber beam hangers, or whatever it may be, fully threaded screw is the most cost effective way to do hidden connections with timber construction. Obviously, if you need to have stronger connections, one would have to look at some other products, but it certainly should be something that the general contractor should be well aware of. It's a fairly simple product to work with. The installation is quite quick and easy, and we can give you design values on exactly how strong that connection will be in a variety of different timbers. Now, the next video I want to show you is a slot connector. And in the second part of the video, we'll see some very interesting statistics on these more sort of, let's call them technical solutions in terms of costing. So maybe upfront your solution or your material costs may be higher, but your installation and your engineering values come down, or your installation times and engineering values go down, and engineering values go up. Next video, and the videos are almost done now, I promise, guys. I think there's this one and another one. This is another very, very interesting product that we use a lot in timber construction. This is a hidden fix shear bracket. You get very, very high engineering values with your alu brackets. Why we look at hidden connectors, be it VGZ, be it alu, be it lock, whichever ones it is you have a couple of really big advantages. Aesthetically, obviously the architects love them. You don't see any sort of beam hangers and that, the sort of steel protruding from your connection. It's hidden from the elements, so you have a resistance to corrosion. And very importantly, you also have very good performance in fire. So when your steel components are encased in timber, the timber actually protects the steel. It's not commonly known, and it goes against what many of us know as braai experts, but timber has very, very predictable behavior in fire, and steel not so much. So the minute that we can sort of protect the steel, the better off we are in terms of increasing your fire resistance in your structures. So yeah, this isn't how the alu bracket works. For the sake of time, I'm going to skip to this last video. This is a product that Rothoblaas has released a few years ago. It's a very, very innovative product. It's sort of light years ahead of its time. And this is a very, very clever way of building big, tall timber buildings without making use or minimizing the use of certainly of beams in terms of post and beam construction. So keep an eye on this. Also look at the your post spacing and look at the actual achievable height of the buildings using these types of systems. So we're a good couple of years away from it in South Africa. I believe it is coming, but certainly with these types of systems, you can see what has been achieved around the world, and hopefully the African continent is next. I'm going to move on to the next part of my presentation now about air and wind tightness, and this is a lot to do with obviously comfort and also durability. I think in our market, durability at this point is probably taking preference over comfort, and I think we will gravitate towards having more well sealed off and sort of passive house principles within our constructions. And why is air and wind tightness important? I think if we just look right now at some of the challenges we have with Eskom is if you've got your air conditioner running, you want to make sure that you're containing that it's heat, and essentially you want to make sure you're containing your heat in your structure. And this is why air and wind tightness, or addressing air and wind tightness, becomes very, very important. Of course, as electricity prices go up, you maybe want to look at investing a bit upfront, making sure it's done properly, and then enjoying the benefit of having an airtight and comfortable structure. There's a few notes on air tightness and wind tightness, the difference between the two of them. I will share this presentation with Samantha afterwards. You guys are welcome to go through some of these notes. But it's just we're just going to touch on some of the fundamentals on it. Of course, thermal performance of a building casing terms of managing moisture inside the building, and never mind just inside the building. We must also remember that a lot of the timber that is, certainly in timber framing, a lot of the timber that we use is almost soaking wet with CCA treatment. And eventually that moisture needs to go somewhere. If you don't address where the moisture is going, it ends up going straight into one's insulation inside the cavity or inside your stud work of your timber frame structure. And the same is true for mass timber for that matter. Certainly if it's insulated or if there's moisture that cannot go anywhere, or you block off one side of your CLT panel and you do not allow the structure to breathe, at some point you are going to pick up issues. As I said right in the beginning of my presentation, one of the golden rules with timber is it can get wet, but you need to make sure it can dry. So one of the most crucial products to make sure that happens is the use of breathable membranes. So Rothoblaas has actually studied climatic areas around the world and have drawn up a fairly generic specification for how one details internal and external walls. In our market, we find that often internal walls are left exposed for visual aspects, and also because as South Africans, we tend to live with our doors and windows open, for the most part. So if we have a pressure buildup we actually generally don't have a pressure buildup in our houses because we have our doors and windows open. So just by design, we do not often have a vapor buildup. But anytime you wake up in the morning and there's condensation on your windows, this is a pressure buildup. So to say that these things are not important, and I've heard it many times, it's actually not true. If there's condensation on your window, you know there's a pressure buildup. You know that in a timber structure, that moisture will get into the walls. I think that, it's my opinion, I think that timber construction has actually benefited from poor workmanship because of gaps around windows and that sort of thing. So generally we've allowed the timber to breathe. But as the technology and the workmanship improves, if we don't use the correct products to allow our timber structures to be both waterproof and breathable, one is going to pick up quite a lot of problems down the line, especially when one is incorporating things like double glazed windows with very good sealing around the sides of them. It's very, very important to understand which route to go. So if we look at this slide, you'll see at the bottom corner, or in Africa, we have a moderate climate, and usually there we would specify a vapor stop membrane internally and a breathable membrane externally, which essentially this means that you're stopping the vapor inside your house before it enters, or inside your structure before it enters the wall space. And should moisture be present in your wall space, it will gravitate, or it will be drawn out to the outside of the structure, and it will ventilate out naturally. If you had to spray a breathable membrane with a hose pipe, that moisture will not go through the membrane. So for me, I come from a strict waterproofing background. I couldn't get my head around how can something be waterproof and breathable at the same time. But essentially, this is how these products work. There's just a few basic principles to respect in terms of designing: deflection, drainage, drying, and durable materials. I always remember anecdotally a guy that I knew. He said you always want to have big boots and a big hat if you're building with natural materials. It's talking about the structure, not actually the PPE. The membranes are split up in two main groups: monolithic and microporous. Essentially, your monolithic is your more technical, advanced material. It works as a polymer, so it's a chemical reaction inside the membrane, as opposed to your microporous. Microporous acts like a filter. So yeah, monolithic's technical. Microporous is possibly more commonly used in South Africa. It's a bit more cost effective. It's a little bit first generation, whereas your monolithic is a far more performance based product. And these are just some of the general characteristics. You pay a bit more for the monolithic, but you get a lot more in terms of performance characteristics. And this is primarily on breathable membranes. A typical vapor stop membrane, we don't sell a hell of a lot of this product in South Africa. This was quite an interesting project we were involved in a few years ago, where the architect used the formwork for his concrete shuttering as an internal wall finish. It was a Belgian guy, if memory serves, and he went, full European spec on his construction. So this is an example of a vapor stop membrane being installed internally, where they've reused the timber shuttering as the wall finish internally as well. Just some basic installation guidelines. Very, very important when considering or installing membranes is one, first of all, you don't want to puncture your membrane with staples. Anytime you staple your membrane, you want to make sure that you're stapling it underneath an overlap, essentially. And any staple holes that you do make in your membrane, you should be taking a small piece of sealing tape and sealing up the staple holes. So Rothoblaas, we do supply. We've got quite a lot of videos in terms of installation, and this is a very typical detail of sort of guidelines of how we propose to waterproof a window. I think if one can waterproof a window with breathable membranes, you're on the right track to waterproofing your whole timber structure. I think this is the most technical part of it. So these are just some general guidelines on how we propose to do it. The last step 8 of it, this is one, or it's not all of those products, just so that you don't think you need to buy 1, 2, 3, 4, 5, 6 or 7 different products to waterproof a window. It's one or the other. And this is an example of a project we were involved with in Muizenberg, where you can see a nicely well-detailed sealed off membrane installation with the cladding. You can see that the brand ring is running vertically in this case. This is good detail. This obviously allows any moisture, water that hits that membrane to run off directly, and it allows hot air to rise and ventilate that cladding detail. Couple of different types of products. We have got a breathable reflective membrane, which will a very, very good solution to steel roofs where you want to increase your R value as well as add breathability. So that we have in a sort of a jumping off point as a Truspier Alu 120. The 120 always refers to the thickness or the weight per square meter. And then we also have fire resistant membranes as well. So now one can start incorporating fire resistance into your cladding, which is always a very contentious subject when it comes to timber structures and certainly cladding. In terms of tapes and air tightness, one would look at a combination of products. It's a bit of horses for courses. What do you believe works? Rothoblaas does have Passive House Institute certification for a number of our products, and we've also detailed it in a way that if you look at our catalogs, we can look at the different nodes and fields of application, inside, outside. Is it exposed? Do we need it to be reflective, non-reflective? And then, of course, we can look at the supports. Now, when one talks about the support, we're talking about, is it going onto brickwork? Is it going onto concrete? Are we going onto membranes? Are we going onto steel sheets? What is the support? And then back again, what is the actual application? So this actually, for the woodworker or for the designer, it makes it quite easy to look and say, okay, yes, this is the right product for us to specify, or perhaps we can maybe look at something else. Also, there is software available free for download. This is called Ubacus software, and this will actually identify where your condensation point is in a typical wall makeup. So, of course, where you have hot and cold air meeting at some point in your wall space, you want to try and have that condensation point outside or as close to your breathable membrane as possible. Of course, we've got UV resistant membranes as well. For example, the one we see here, this is not UV resistant. You would be covering that completely with steel sheets. And on something like this, you would be seeing through the cladding onto a matte black membrane, which is completely UV resistant. So just a few different applications. How are we looking for time?
Sorry, Bram, you go.
Mark, if you can wrap up, just we can give Michael a chance as well.
Okay, I beg your pardon. All right, I'm going to leave it there for now. The last bit was on acoustics, but that we can tackle at another stage. Thank you very much.
Thank you, Mark. Yeah, so appreciate that wisdom. There is a question in the Q&A for you, but we can tackle that a little bit later after Michael's spoken. So we can hand over to Michael. Thank you very much.
Hi, everyone. I'm Michael Kloos. I'm going to be presenting on structural connections for mass timber buildings. Just a quick overview of my presentation. I'm going to start very briefly with a personal background, which has already been covered, actually. Then I'm going to discuss the kind of general nature of timber connections, then types of connections, how we design these connections, fire, some practical tips that I've developed over the last few years, and then finally, what is the cost of these connections? So I'm a professional engineer. I've been working for 5 years now. I'm based in Cape Town, and I've done a number of CLT buildings over the last 3 years. Also spent time assembling the buildings and, yeah, gotten some design as well as practical experience. So the nature of timber connection differs in some ways from concrete and steel. So for concrete, the sections are monolithic because you cast concrete. It's all connected as one. You don't necessarily design the connections. You just make sure the member is big enough and there's enough steel. For steel, connection types are limited to bolts, welds, and pins, essentially. For timber, we have a plethora of methods available to us. There's a huge variety. If you see what Mark presented now, there's actually an overwhelming number of ways to connect timber. So you have to choose the way that works for you and that is applicable to your project. Furthermore, unlike steel, concrete connections in timber buildings are often the weakest part of the building because timber is usually sized for serviceability, so that means deflections and other criteria, not for strength. So you don't necessarily design the connection to be stronger than the member itself. So if a timber building fails, it would most usually fail at the connection, which is not a problem as long as your connection is designed to withstand your design loads. Also, especially for mass timber and these modular systems, the connections are absolutely critical for rapid and easy assembly. So mass timber is often hyped as a fast assembly method and all these kinds of things. But if you don't design your connections well and plan for them, you can make or break your project with the connection design. And in fact, on that note, I think in terms of my buildings, I've spent sometimes more than half the time actually on the connections and not the actual sizing of members. So how do mass timber connections vary from regular timber connections? I would say not actually that much. It's mostly the same or similar. Of course, with these proprietary systems and plates, we start getting more and more specialized, but usually the way we connect would be quite familiar to most carpenters and people. So the connection types that we have are pure timber connections, nails, screws, plates, and then proprietary systems, which are specialized systems developed by suppliers. And then within each of these, again, we have a multitude of differences. So firstly, I'm just going to briefly touch on pure timber connections. So for centuries, this was, of course, the only way you could connect timber. And it can be very effective, but it, of course, takes much more time. And these days, almost all timber connections are steel. That said, these connection types can be highly sophisticated. If you look on the right, the Japanese especially are well known for these kinds of connections. And with the aid of CNCs and robot precision, it is actually an option to explore when you design a connection. Then moving on to nails. So Marcus mentioned some of these things before, but yeah, it's the predecessor to the screw. It's very simple. It's very cheap. It's very fast, especially with a nail gun. And for mass timber, it can be used effectively with plates. You don't typically use it to connect a beam to a wall, say, but they are used with plates. And yeah, but the axial capacity of a nail is way less than a screw because it relies on friction and not on, there's no thread. But in shear, so in sideways force, it compares very favorably with screws at a fraction of the price. Then we're moving on to screws. So these are common, versatile, and familiar, cost effective when compared to steel plates, but not necessarily. And they have a very high axial capacity due to the thread. But when it comes to screws, there are many different types of screws. And it's very important to understand the difference, which Mark has touched on. I'm just going to go into a little bit more technical detail, I'll say, and I'm going to focus on the three main types of screws that I think are relevant to mass timber structures in South Africa and the ones that I've used the most. So we have the partial thread screws, which are quite familiar. As Mark said, they're like chipboard screws. What's very important when you use one of these screws is that if you want to use it to clamp two pieces of wood together, the shank, so the smooth part, must be longer than the thickness of the outer member. If that is not the case, you lose that ability of clamping, which you really typically want when you're installing your building. The shear force or shear resistance of these screws is very good. But the axial capacity is not very good, and it's governed by the head and not the thread. So the type of head has a big influence here. You've got your typical countersunk heads, and then your mushroom heads or your flange head screws, which have a much higher pull-out capacity. So within the partial thread screws, again, you've got variations, which one to use. Then we move on to full thread screws. These are specific to structural timber. And yeah, a lot of this has been said by Mark, so I'm not going to repeat it. But in terms of its clamping ability and not, a common construction methodology that I've used and I've seen often used is that during your assembly phase, you use partial thread screws to clamp your building together and align it. You need far less screws because your building isn't experiencing its design loads yet. You can actually hold your whole building together with very few screws. And then once everything is aligned, square, flush, you come with a second round of what I would call the structural fixing round when you come with your full thread screws. Because once your full thread screws are in, that building's going nowhere, and you will never be able to move those panels again unless you remove the screws. But that's not really going to happen, and it's a lot of work to do that. So you don't put full thread screws in during the assembly phase. It's more the next round of structural fixing. They are also much more expensive than full thread screws. I believe the reason for this is that it's the thread that is the difficult part to manufacture. So then the last screw I want to talk about is the timber to metal screws. So these screws have got a widening underneath the head, which makes it sit flush in the plate. If you use a normal screw, the thread is wider than the hole, which means that your shank will be loose within the plate, unless you provide a countersunk hole. But this is more difficult than just drilling a hole right through. So these kinds of screws are important to use when you use steel plates. Yeah, so those are the three types of screws that I think are the most important, the ones that I specify the most. But for instance, the Rothoblaas catalog has more than 50 types of screws. It's quite overwhelming. But a lot of the screws are only slightly different from each other. They are not fundamentally different necessarily. And a resource that I recently came across was this smart book for timber screws, which you can download from Rothoblaas. It's a nice intro to screws. It explains a lot of the things that I talked about now in a bit more detail. It's something I wish I had 3 years ago. So that is available for engineers who want to know more. Okay, then we move on to plates. I think in Mark's videos, you saw some of these kinds of plates. They have a much higher strength and rigidity than screws. And these you will start to use in bigger buildings. For a small building, you're not necessarily going to be specifying these plates. You get L brackets, flat plates, thin plates, to concrete. There's a plate for every kind of application. to see what's available. And it's also nothing new off the shelf. We use these kind of MyTech brackets in timber construction all the time. So you get very sophisticated fancy plates. My next slide shows, you know, on the left-hand side, you see just a flat, basically piece of steel, some holes drilled into it, and it's bent. And this is cheap and easy and familiar. And then you get these extremely sophisticated systems like the Spider in Mark's video, or this is another system, the X-Rad, which is also a kind of proprietary system / plate. But I wouldn't say that these are applicable to South Africa yet. The nature of our buildings just doesn't call for the complexity of this kind of connection. So how do we design these connections? The two main criteria are strength and durability. For strength, the structural design codes give methods. Eurocode is quite advanced. The SANS code is quite not simplified. It's crude is maybe a bit harsh, but it doesn't nearly have the same detail that the Eurocode has in terms of the axial pull capacity of screws, the shear capacity, all these kinds of values. But what's also very useful is that suppliers such as Rothoblaas have catalogs and design guides with tabulated resistances for screws and plates in various geometries. And this is extremely useful for doing design, especially early stages when you're trying to size these members. Important to understand is that you need to ensure edge distances and spacings between screws is okay. You can't put them too close to each other. You need to have minimum distances. Also, the number one thing that affects the strength of a screw or head is actually the density of the wood. It's not the tensile capacity or the compressive capacity. The denser the wood, the more effective your screw or nail will be. Then the second most important thing I would say is durability. So these are all steel, and of course steel rusts. What's quite nice about screws is that they're embedded in the timber, and that protects them from rust actually. Plates are more exposed, so you've got to make sure that they're galvanized or painted or even both, especially if they're on the outside of the building. What's also to keep in mind is that timber species and the treatment thereof can affect the corrosion. So as far as I know, CCA and SA pine do not have a significant effect, but it might be if you use some exotic wood or some new kind of treatment or something like this. You just need to make sure that there's no adverse chemical reaction that can happen there. Connections and fire. Steel gets hot. As it gets hot, it gets weak. This is super important. So as I said, connections are the weakest part in a building, and in fire, they are definitely the absolute weakest part of the member. If you don't design your connections for fire, your building will only could last minutes, potentially. So again, what's nice about screws, the humble screw, is that it's embedded in the timber, so it's hidden, which protects it. Steel plates are much more vulnerable, but the solution there is to box them, to hide them. If you see on the left, you can see there's a nice fin plate there, which is completely encapsulated in timber. Important is that the gap between the beam and the other beam or post or wall needs to be quite small. I think the Eurocode states it cannot be more than 2 millimeters, but you never know what it's going to be on site ultimately. So you need to basically caulk that gap. And for that reason, you get intumescent tape products. If you look on the right, you can see there's a black tape that's wrapped around the plate that seals that gap so that the hot gases can't get in and heat up your steel. This slide is quite nice. It just shows how embedding your screw deeper in the timber and plugging it. So on the right-hand side, you can see the screw, and it's deep in the timber, it's plugged, and it hardly causes any accelerated charring in the timber. Whereas on the left, the screw is not embedded, and there's a lot of accelerated charring around that screw. Interestingly, though, if you look, it still doesn't go all the way down. So even if a screw is fully exposed, it only accelerates charring about 30 millimeters beyond the primary charring layer, which is actually another reason why screws are quite nice. They perform well on fire. So some practical tips is keep it simple. This is the number one rule, I would say. the less types of screws you have on site, the less mistakes there are going to be. If you need a 120 millimeter screw and a 140 millimeter screw and a 160 millimeter screw, I suggest you just use 160 millimeter screws. Even though it's less economical, you're asking for trouble if you've got 10, 20, 30 different types of screws on site. It's always mistakes. In the same thought process is then to have consistent and repetitive details, so the same spacing. Again, so if you have 200 spacing, just use 200 spacing everywhere. Again, it's not economical, but the cost of connections relative to the cost of failure or the risk just doesn't make it worth trying to economize and overcomplicating connections and then having it installed incorrectly on site. And then different horses for different courses. I think the complexity of connection detailing is proportional to the size and complexity of the building. For small buildings, you can easily get away with just using screws and maybe a few plates here and there. It's only for really big buildings when the forces and seismic forces become important, where you need fancy plated connections. Tip number 2, consider fire resistance early on in the design process. So find out if your building needs a fire rating, what that fire rating is, 30 minutes, 60 minutes. You really don't want to be caught down the line with connections that are going to fail in the fire, and now you have to modify your design, and which usually means an increase in cost. So just think about that, keep it in mind early on. And then tip number 3 is that a useful rule of thumb for timber connections is that a large number of smaller diameter screws or nails or dowels perform better than a small number of large diameter connectors. So basically spreading the load. So a big plate with, say, 20 nails will perform structurally better than the same plate with 4 massive screws going in. It just spreads the load more throughout the timber and it disturbs the grain of the timber less. So that's just the rule of thumb to consider. Of course, it has a time implication though, but time in South Africa is still relatively cheap. So rather go with more small screws than less big screws. And then finally, how much do these connections cost? So this is always the big question, and it's super important early on in the project during the costing phase to have some kind of idea of what these things are going to cost. So unfortunately, our data pool in South Africa is very small. It's not consolidated. We don't have 100 projects. I only have access to kind of my projects, the costing, and I haven't done it on all of them. But you know, and obviously it also depends a lot on various factors. Are you using screws or plates or proprietary systems, and which supplier are you using, and are they giving a discount? And there's so many factors at play. But I'll just give one case study. So a residential house that I designed, 64 cubes of CLT, so relatively large double-story building, full CLT shelves, so floors, walls, roof. The total cost of the connections, and this was only screws, including the handling fee of the contractor, came out to 700 Rand per cube of CLT, or 4.1% of CLT costs. Now, I prefer to use the cubic meter rate because that separates it from supplier cost or possible discounts, things like this. So if one supplier is cheaper than the other or is offering a discount, it's not going to affect the price of the connection. So rather work on a kind of geometric level, a square meterage or a cubic meter of CLT. Big disclaimer, this is only a single project. This could vary. It did compare similarly to another building I did that costing on. But yeah, you don't just use this on your projects. It does depend, but it gives one an idea of how much this costs. Interesting to note is that the membranes and tapes were actually more expensive than the structural connections. So it's not just the steel that's expensive, all the membranes and tapes and architectural detailing, if I can say it like that, the second and third points that Mark was talking about, it also has a cost implication. Yeah, and then the wood app, so that's already been discussed, but I just want to make everyone aware that there's a new course coming up end of this month, prepared by myself, and it discusses the structural engineering of CLT. It's a resource I wish I had 3 years ago when I started. So I encourage everyone to check it out. It's specifically aimed for engineers, but any building or any professional in the building environment can find, I think, value in the course. Thank you.
Maybe I'll start. I want to ask Michael, the fire consultant, obviously on residential buildings, you don't always have a fire consultant ready on hand, but how quickly will you get that fire consultant to dovetail your details with typically in a project, in the process?
So the fire engineer, they can't actually really comment on the structural capacity. They will actually rely on the structural engineer in these cases. So, fire engineers deal more with the airflow within the building and these kinds of things. So I found that it's up to the structural engineer to specify those details. It's not going to be done by the fire engineer, who are usually mechanical engineers. I don't know if, yeah, so I think but this detailing will only happen, stage 4, basically. And on a stage 2 level, I would just allow for more, I would just give a bigger allowance for the fire connections. Does that answer the question?
Yeah. And maybe Marcus, maybe you can comment on that multi-story building in Zanzibar that you were involved with, at which, well, because that's always for us as architects, our greatest fear is always the fire engineer is not moving with us in the same direction as what we want.
Yeah. I mean, it seems like we do a lot of work up to stage 4, and then the fire engineer rocks up and just covers everything in gypsum. That's more or less how the process seems to flow. But on our case for that structure, there was a quick consultation with the fire engineer quite early on in the project's sort of conception. At that stage, some of the more important characteristics wasn't really around the connections. The connections were always intended to be quite well protected through some specific detailing. I'm sure I can find that detail for you guys if you'd like to look at it. But really it came down to taking care of some of the more sort of primary structural members in terms of the glulam and the CLT floor structure, how many layers were required for those certain structural elements to really be within the required fire rating, which is obviously determined by the number of levels and escape routes and all of that. So quite early on, there were some design restrictions put into place, but the emphasis on connections and physical steel work and screws, there wasn't much around that. It was really more about some of the core aspects of the building that needed to be covered. So the thickness of your floor slab, how your beams and columns kind of met the rest of the structure, and then how those points were well protected.
So to Michael's point, Michael, say if your structural engineer is not awake from the start in terms of fire, you might run into problems later on in your process.
Yeah, everyone needs to be awake on it. Fire engineers, structural engineers, and architects as well. Understanding there's more and more research being done into this, and more things are coming to light. Fully exposing the inside of a CLT building is also problematic for fire reasons. We've now seen it's unfortunately quite a complex field, and there's not one person who can give you all the answers you want in terms of fire. It's a collaborative approach between fire, structural, and architecture.
Thank you. And Scott, do you want to field the question?
No, but I think we can carry on to some of the questions in the Q&A. So I think the first question was from Francois, and his query was to Mark: do you or your HQ offer designers, installers, hands-on physical on-site courses?
Thanks, Skulk. Duncan, thanks very much for answering that on our behalf. Yes, we do. We do have there's very technical headquarter courses. The one is called, well, it's a TEW. It's a week-long course for engineers in the headquarters. That's the very high level technical course happening at Rothoblaas at the end of this year. And then we also have a what they call Rotho School on Tour, where one can do a hands-on installation, either a local installation course with full-size members, but just obviously in a much smaller piece, where we can actually use the same screws. It's not a little mock-up, it's an actual full-size, small, call it like a dog box, where you can build it together, detail all the CLT, detail the waterproofing, detail the screws. So to answer your question, yes, we do offer these courses, and possibly next year we'll be looking at bringing a theory and practice course to South Africa.
Then the next one was my question, and I posed it to Mark, but I would actually like to pose it to all three of you, and even Bram can also add to it. What, in your experience, what are some of the common misconceptions that you have encountered regarding timber connections, and what are your answers to them? Mark, maybe you can start.
I think that the most common one, and Michael touched on it, is the bigger the screw, the stronger it's going to be in the connection. I think there's a lot of misunderstanding, certainly in South Africa, with thinner timber sections. You're not going to win with a very big screw in a very thin timber section. This is now, we're not talking of the mass timber guys, because there your minimum distance has become a little bit more flexible because you're using bigger sections. That would probably be the first thing I've picked up. And I think from a quality point of view as well, is the guys that are using the screws are sometimes, they're not really sure what they're actually buying, so they don't see the value in buying certified products in some instances.
Yeah, thank you. Michael, anything that you've personally seen often?
Yeah, I guess there's many misconceptions. I think, yeah, the one is the full thread, partial thread thing. People don't understand that. It's like a fundamental thing. Also the partial thread, clamping two pieces of wood together, it's critical. If you put a full thread screw in at the wrong time, it's really bad. Sometimes you can't even get them out. It snaps. Yeah. So, and then the next misconception I think is how strong these screws are. It's quite phenomenal. If you try to pull out one of the full thread screws, I've seen a whole building being picked up on a full thread screw. So it's quite phenomenal that they don't necessarily inspire confidence sometimes just looking at screws, but from just seeing what they can do, they are very high strength connections. Another misconception, at least for me, if you pre-drill a hole in timber with a screw, it's actually going to provide a higher strength connection than a non-pre-drilled hole. I used to think, the screw going in and crushing the things and it's denser around, but it's not actually the case. If you pre-drill the hole, the thread cuts better into the timber and it's actually stronger. But that said, in SA Pine, you're wasting your time pre-drilling. You might as well just drive that screw in. You can drive in 7-8 millimeter screws, no pre-drilling, easy with an impact driver, and it's just not worth the time. But it is an interesting point that pre-drilling is higher strength. I can't think of any others right now, misconceptions.
I think to jump in, I find that when we start engaging with projects that eventually need to head to site, there is a bit of a misconception that it's very complicated to put together connections. And what we've seen is that because of the fact that designing with mass timber kind of leans quite heavily on a strong design process with engineers that know what they're doing, which is quite untypical for conventional building, because it's just sort of whoever, and there's a standard way of building and it's pretty well understood. But once things do arrive on site, due to the fact that, building information modeling is taking care of quantities, where connections go, how they meet each other, a lot of the detailing is done, and the fabrication is complete in the factory. When it gets to site, it's not that complicated to put it together. So sure, to a certain degree, you might need a little bit of specialization and understanding of how to ensure that you've put the screw in correctly. But besides that, it's as simple as putting a screw into a piece of timber. So that misconception, I think, is something that we need to work on as a collective, as well as building with timber is easy. We just need to have the right information in front of us.
Then the next question was from Duncan. It's quite a long question, but I think the gist of it is, Mark, specifically skewed screws. So for example, if a screw needs to be installed at an angle, that obviously is more difficult than to put in a screw perpendicularly. So the question is, for example, do you have like a jig or something that installers can use, or how do you assist installers with putting it at the right angle?
Yeah, there is a jig available. Look, generally the rule with full thread screws is you want to get as close to 45 degrees as possible. So we do have a jig available that can show you your minimum distances and your edge spacing and that. Stainless steel laser cut jig that we can supply with the screws. Alternatively, a carpenter could create a little wedge that he could use as a jig on site. And one must also keep in mind that, as Michael was saying as well, is he often clamps the two elements together with a partially threaded screw, and then you can lock it in. So, because these screws do not pull everything together, you can have a tendency where the fully threaded screw can push the other element out of position. So when you actually, when you finish driving the screw in, you might have started where the two elements were level and they might not finish level. So once you can clamp them in with a partially threaded screw, you obviously, most of your work is done for you. The other thing to keep in mind is if you're worried about the finish, these screws can be inserted. You can be quite creative in how you insert the screws. So of course, if you're looking at a beam from the floor looking up, you would insert the screws from the top down. Conversely, you could put them also from the outside going in, if that makes sense. So you could make it that where your head is visible is only the carpenter will know that the head is visible there. The person actually making use of the building, unless he goes and physically looks for it, he won't find it.
Okay, thanks.
If I can add the last thing with the elliptical plug, the way we've done it is actually just oversizing the hole. So the greater the angle, the bigger your hole needs. So you drill quite a big plug, like a 12 or a 16, and then you drive your screw in an angle and then you plug it. So there are ways around it. Yes, it's harder to drive it in an angle without a jig, but it's not impossible either. You kind of push the screw in straight and then you drill a little hole and then you put it out and then you come in an angle and you come down. But if you can go straight, then that is easier. There's no doubt about it.
Okay, then Duncan made a couple of comments. Firstly, my alternative is that it is better to pay for a bracket rather than stuff around with skewed screws. Maybe you can comment on that.
Yeah, ultimately it's preference. So it's a preference. There's no right or wrong here. It really depends. It's a factor of cost, time, ease. Like I said, the plates, if they're exposed, you've got a rust corrosion issue. There's a lot of things, and it really, there are so many ways to connect two pieces of timber together. There's definitely a preference aspect to it as well. There's no silver bullet.
So I think also a hidden plate connection will take a lot higher load, but you need quite specialized kit to do your slot cut for your plate. This is a significant cost, but at the same time, then you're getting a lot more with your plate. You're getting much higher insulation, much higher engineering values, and so that would be you can't really compare the two. If it was the same load, of course, one would then look at going the plated a plated connection as opposed to 13 screws in terms of time.
Okay. Is there anyone else in the audience that would like to ask a question?
Not seeing any more questions, Skulk, that have come up. And there are no hands either. Should we move to close?
Yeah, I think so.
Great. Thank you, everybody, and thank you for all your insights, your answers. Thanks for the audience for being engaging. We really appreciate it. I did put a poll up a short while ago just to understand if this is your first or your second or fourth or fifth webinar. But with that, I'd like to hand over to Tafadzwa Nyazunda. She is the Director of Forest-Based Industries with the Agro-Processing and Forest-Based Industries Unit at the Department of Trade, Industry and Competition. She has a very long title, but I'll leave it to her to do some closing remarks and a vote of thanks.
Thank you, Samantha. Before I just execute my duty or for this morning, I just want to invite everyone that is linked, that is on this webinar, to join the LinkedIn group that has been created with the purpose of promoting timber in construction and also to join and contribute in the conversation. We also want to invite you to join the Facebook group. I've put in the link, and we also want to enrich those conversations that are happening there. The Wood app has been spoken about by Michael, as well as I think Samantha, when she was introducing, she talked about the Wood app. So you're welcome to take the courses that are on the Wood app. So we have a few things that are going to be happening in the next month, this month and next month. First is the timber construction workshop that will be done at Stellenbosch University on the 30th. Kindly join. Secondly, we have the research colloquium that is also going to happen at University of Pretoria on the 11th of September, and then followed by the Timber Construction Conference on the 12th of September. So there's quite some activities that are going to be happening there. If you have missed any of the webinars that we have been doing, I think this is our 7th, Samantha? Should be our 7th.
I've lost count, but I think it is around us.
8. So we have a series of these webinars that are addressing different perceptions about construction in timber, that are addressing different topics in construction of timber. So you are welcome to visit the Sawmilling SA website or their YouTube channel and watch those webinars if you have missed them. So now I would like to thank our presenters today, Michael and Mark. Thank you very much for accepting to share the knowledge that you have, freely doing so. I still continue to thank our previous presenters. As you go through the webinars, you will get to see them and to meet them. I want to attend the people that have responded to our invitation to attend this webinar. I can see that it's quite high and the numbers, they keep increasing. So we are definitely doing something. We are communicating the message. And to our sponsors, we are forever indebted for spending so much time and your resources in supporting this good cause. Sawmilling SA, SOPA, University of Stellenbosch, University of Nelson Mandela, University of Pretoria, the Pretoria Institute of Architects, and Earthworld Architects. If I have left you, you've partnered with us, you have sponsored one of the webinars, please just know that we are thanking you from the depth of our hearts. So the sawmilling industry as well as the engineered timber manufacturers. I'm very happy to say that because when we started having these conversations, we were not making any of the engineered timber in South Africa. And now I can safely say that I know 4 companies that are making engineered timber here in this country. And thank you for representing us, or those that are represented here today. Thank you for the great work that you are doing. I know that we have a whole lot of work ahead of us, given the percentage of buildings that are built in timber in South Africa. I think we are just around 1%, whether it's above or below, but we are somewhere there. So we want to increase this percentage. We want to do good to the environment, and we want to continue constructing in timber. So thank you for our webinar organizer, Frog Communications, and program director, Samantha. You keep on doing the great work. So thank you all for dedicating your Thursday lunch hour to this cause, and I'm hoping that we're going to meet you in person, either at the colloquium or at the conference. Thank you once again. Thank you. Thanks, Samantha, over to you.
Thank you, Tafatwa. Yes, thanks to our speakers. We were giggling earlier. We have Michael, we have Marcus, we have Mark. When we don't have them, we have Brant, Bram, or Bruce. So if you're Tandi, Tom, Trevor, or Tabo, let us know, and we can probably do a webinar with you. But yeah, please reach out to us. Joy Crane from Woodbiz Africa has put a link in the chat for summaries of the past webinars, and as we mentioned, they are on Sawmilling South Africa's webinar. So this will come. This will be uploaded in the next few days after a few edits, and then you can just continue reaching out to us and engaging with us. And if you'd like to be added to our mailing list, please do. So really, thank you from us, all of us, and yeah, let's continue to build with timber and have the right connections.